jhat 塾
Please hit subscribe.
This problem appears at the qualifying examinations for applicants for Japanese government on MEXT scholarships 2019. There are two mathematics exams, one for social sciences Mathematics A and another for natural sciences Mathematics B. This problem is from the 2019 Mathematics B questionnaire. The answer key and the original questions are linked in the description. Problem 1 to 3 of 3. Let f of x equal e to the x, g of x equal 1 plus x, and h of x equals 1 plus x plus 1/2 x squared. Fill in the blanks with the answers to the following questions. The first question is, when x is less than 0, arrange f prime, g prime, and h prime in ascending order. The second question is when x is less than 0, arrange f, g, and h in ascending order. Then we are asked to compute I sub 1, which is the integral from -1 to 0 of the absolute value of f minus g. Then we compute I sub 2, which is the integral from -1 to 0 of the absolute value of f minus h. For this problem, it is useful to recall this definition or this way of expressing the absolute value of a function f of x. In general, the absolute value of a number is equal to just the number itself if the number is positive or equal to 0, or it is equal to the negative of itself if the number is less than 0. So by doing this, by expressing this expression in terms of this and this, when we know the intervals where it is positive and negative, we can get rid of the absolute value symbol, and therefore we can do the regular algebraic manipulations to the function. Then let's also recall the derivative of f of x, which we denote here with f prime of x. If the derivative is negative, that is less than 0, then in that interval, f of x decreases. That means that from left to right on the x-axis, the value of f of x decreases. So it gets smaller and smaller and smaller. On the other hand, if f prime of x is positive in that interval, then the value of f of x from left to right of the x-axis increases, so it gets bigger and bigger and bigger. We are asked to compare the values of f, g, and h when x is negative, that is when x is less than 0. We are also asked to do that for f prime, g prime, and h prime, which are the derivatives of f, g, and h respectively. To do that, we can compare the values of f and g first. Then we also do that for f and h. Then we do that for g and h. If we know the comparisons, meaning which one is bigger and which one is smaller for each of those two comparisons, then we can actually have an idea on which one is the smallest and which one is the largest. For example, if we know that between f and g, f is smaller, and between f and g, or rather f and h, f is again smaller, then we can say that f is the smallest between or among the three. Then we will have to look at g and h. Whichever is larger would have to be the largest among the three then. So that is the strategy we will employ here, both for the functions and their derivatives. So we will have a look at those three comparisons, f, g, g and h, and f and h. How do we compare f and g? How do we know which one is smaller? The most straightforward way is to get the difference. Let us try to get the difference between f and g, f minus g, because if that difference is negative, that means that f is less than g, right? Because we got a negative when we did f minus g. Otherwise, if it's positive, then we know that f must be greater than g. And if it's 0, if f minus z or f minus g is 0, then we know that f and g have equal values. So that's what we will do for f and g, g and h, and f and h. That's what we do here. We define a function u of x to be the difference between f and g, v of x the difference between f and h, and w of x the difference between g and h. And then we just substitute the values here, these values for each of them. And so for example, for u of x, which is the difference between f and g, what we get is just f, which is e to the x, minus g, which is 1 plus x. So we get this. And we do the same for v of x and for w of x. And then we try to see if it is positive or negative. So the easiest case is actually w of x. We see that this is negative 1/2 x squared. Whatever your value of x is, we know that x squared could only be positive or 0, right? So if we add if we multiply it with a negative number, which is negative 1/2 in this case, then this entire value would always be negative. That means w of x could only be negative or 0, whatever x is. And that means that g of x could only be less or equal to h. Again, that's because we have a negative difference. And so we already know that. So we write it down here. Going back to u of x and v of x, we get these expressions. And it's not really obvious whether they will be negative or positive. And so it's quite not straightforward to tell whether f is greater than g or f is greater than h. We'll have to employ a different strategy. What we will do is we try to find the value at 0. Okay, so if we have x equals 0 at this bit, we'll want to know the value of the difference, that's u of x. Let's say it's here. And then what we will do is we will try to find what happens in the interval that we're concerned with. That is the interval where x is less than 0 or negative. If the function u of x goes like this, which is continuously increasing from left to right, then we can actually say that, well, maybe the value of this difference could be negative somewhere, right? Because if it just continuously gets smaller as we go to the left, then somewhere there it would have to be negative. So we can make that conclusion. And so this is the strategy that we'll employ. First, we need to find the value at x equals 0. So what is u of x at x equals 0? And so we just substitute 0 here and here, and we see that that's going to be 1 minus 1 minus 0, 0. The same is true for v of x. We also get 0. And for w of x, although we're done with that, but just for completeness, we substitute 0 here, and again we get 0. That means u, v, and w are all 0. And we already mentioned that when that happens, f, g, and h are actually equal to each other. The next step is to get the derivative of u, v, and w. Or actually, w, we don't have to bother about w anymore because we already know what's going on with w. We already have this conclusion here. So we're just interested in u and v. Now, why the derivative? Derivative because if we already know the value at 0 in here, and we already do, if the derivative is positive, what that means is that to the left of 0, the value of, let's say, u of x just keeps increasing until it reaches 0. That's what it means for u of x to have a positive derivative. If the derivative is negative, that means that the value of u of x just keeps decreasing until it reaches 0. So clearly, if we have a positive derivative, that means that to the left of x equals 0, u of x is always negative. Again, that is for a positive derivative. If you have a positive derivative, u of x is always negative until it reaches 0. On the other hand, if we had a negative derivative, then u of x has always been positive until it reaches 0. And so that's the strategy. So let's compute those derivatives and see if they're positive or negative. Let us differentiate u of x to get u prime of x, and that's just this bit here. And let's do that for v of x as well. So we differentiate this and we get this. And we notice that this is actually equal to this, which is just u of x. So we just write u of x there. It might come in handy later, so we just put it there. Now, we'll have to think whether e to the x minus 1 is positive or negative when x is less than 0. Again, we're only looking at x equal or x is less than 0 because that is the interval where the problem is interested. We will get that answer by noticing that e to the x is actually less than 1 when x is negative. And if you're not convinced, you can draw yourself a graph of e to the x. So here we have x equals 0 here. That's the y-axis. And in fact, the graph of e to the x looks like this. Just keeps on increasing, and it crosses the y-axis at 1. That means that when x is negative, all of the values that you get are actually less than 1. And that's all we need here. When x is negative, e to the x is less than 1. And something that is less than 1 minus 1 is actually negative. And so we can say that u prime of x must be negative. So we write that here. And we already mentioned that if the derivative is negative, that means that it had to be decreasing until it reaches x equals 0. And so we draw that arrow here just to illustrate that that is what we now know. And if so, what that tells us about u of x is that before it reaches this bit, which is 0, it had to be positive. Because the only way you can decrease to 0 is that if you began somewhere positive, right? And that's why we know that u of x must be positive. And therefore, this value here must be positive, which means that this value must be less than this value. And that's how we got this. We now know that g of x must be less than f of x. Again, that's because we have learned that before x equals 0, to the left of x equals 0, u of x must have been positive. Now, if u of x were positive, then this value here must be positive as well. And that is just v prime of x, and therefore we have something to write here. We now know that v prime of x is also positive, and if v prime of x is positive, then that means that it had to be increasing before it reaches 0, right? And the only way you can increase to 0 is actually if you start out negative. And so we can say that v of x must have been negative to the left of 0. And so this expression must be negative, and therefore this expression must be less than this expression. And that is how we got this bit. And now it is clear that g must be the smallest among the three, and h must be the largest among the three when we are talking about the interval where x is less than 0. Here we just write the conclusion that we obtained from the previous slide, and actually this is number 2 on the questionnaire. Next, we will try to compare the derivatives f prime, g prime, and h prime, we will employ the same strategy. First, we define the difference between the derivatives. U prime is the difference between f prime and g prime. V prime is the difference between f prime and h prime, and w prime is the difference between g prime and h prime. So we get their values at 0, and conveniently, again, we get just 0 for all three, which means that all three derivatives are equal when x equals 0. Then we obtain the sign for when x is less than 0 of the derivative of this bit. So we first get the derivative. U prime prime is just e to the x. V prime prime is just this, which is, by the way, equal to u of x from the previous slide. Or rather, u prime of x, which is from the previous slide. And w prime prime is just -1. And again, u prime, v prime, and w prime are all in the previous slide. So we just differentiated them to get their derivatives. Now we just need the sign of these three. For w prime prime, it's -1, so it's obviously negative. And we already know that when you have a negative derivative, then that's decreasing right until it reaches 0. And that means before 0, it must have been positive. And so w prime must be positive. And that means that g prime must be larger than h prime. Remember that w prime is g prime minus h prime. So if it's positive, then g prime must be larger. And so we write this. Now, u prime prime, again, is just e to the x. And e to the x is always positive wherever you are. Although you are less than 1, when we have x is less than 0, that less than 1 is still above 0, right? You cannot have e to the x to have a negative value. The whole function must be positive, even if it's less than 1. And so we have a positive here, and positive means the function is increasing right until 0. And the only way you could increase to 0 is if you had a negative value to begin with. And that means that to the left of x equals 0, u prime must be negative. And because u prime is f prime minus g prime, then we know that if this is negative, then f prime must be less than g prime. Then we do the same for v prime prime. Again, we already know this expression here. This is just u prime from the previous slide. And we already said that u prime is negative. And we said that in the previous slide. And so if it's negative, then again, it's also decreasing, and it could only have been positive before it reached 0. And because v prime here is just f prime minus h prime, then for that to be positive, f prime must be greater than h prime. And from these three, we can see that h prime must be the smallest because it's smaller than f prime and g prime. And g prime must be the largest because it's larger than f prime and h prime. So g prime here. And so this is the answer for question 1. For the third problem, we are asked to find the definite integral of this absolute value of the difference between f and g. And for the second integral, that's the difference between f and h. So we notice that this is just f minus g, which is u of x. And here we have f minus h, which is v of x in the previous slides. And we are looking for the definite integral from -1 to 0. So we are looking at the interval x is less than 0 and greater than -1. So let me just write that down. 1. So this is the interval that we're looking at for that integral. Now, We can remove the absolute value symbol by using this. And we already know that f minus g, when x is less than 0, f minus g is actually positive because f is greater than g. So we can just remove the absolute value symbol because it's positive anyway, and we'll just get this. Now this is easy to evaluate from -1 to 0. And so we just do the integration. So this is what we got from the previous slide for the difference. And when we do the integration, we get this. We just substitute the zeros and the -1s, and this is what we obtain. Now for the second integral, again, the procedure is the same. First, we eliminate the absolute value symbol, and we already know that f is less than h. And so f minus h must be negative. And if it's negative, then to eliminate the absolute value sign, we need to add in a negative sign in front. And so we eliminate the absolute value symbol, we add in a negative sign, and when we add a negative sign, that flips the order of these two. And so we have h minus f this time. And if we just substitute the h and the f's there, this is what we obtain. And finally, when we do the integral, we get this. We just substitute the limits of integration, 0 and -1. And finally, we just simplify that, and this is what we obtain.
If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!